At first, nothing looks different. The waves still rise and fall. The horizon still cuts the sky in half. But somewhere beneath the surface, something ancient is gone. Begins to drift out of balance. The change does not arrive with explosions or tidal waves. It arrives quietly in laboratory readouts and confused whispers from marine researchers. Coastal monitoring stations detect a sudden drop in salinity. At first, it is dismissed as equipment failure. Sensors are recalibrated, samples are retested, but within hours, ships thousands of miles apart report the same impossible result. The Atlantic, the Pacific, the Indian Ocean, all of them are fresh. Fishermen notice something before the scientists confirm it. Nets come up lighter. The water feels different against their skin, almost soft. In aquariums and research facilities, saltwater fish begin to behave erratically. Some sink, others float near the surface, gasping. The delicate chemical balance that has defined Earth's oceans for billions of years has shifted overnight. Salt in the ocean is not seasoning, it is structure. It governs density, circulation, and the invisible machinery that regulates global climate. The ocean's salinity drives thermohaline circulation, a planetary conveyor belt powered by differences in temperature and salt concentration. In the North Atlantic, cold, salty water sinks and pulls warmer currents northward. This process stabilizes weather patterns, distributes heat, and quietly maintains the conditions that human civilization depends on. Without salt, density changes, fresh water is lighter. It does not sink in the same way. Within days, the great ocean conveyor begins to stall. Satellite data shows subtle but alarming shifts in surface temperatures. Warm currents that once flowed toward Europe weaken. Atmospheric models begin to flicker with instability. Marine life suffers first. Most ocean organisms are adapted to a narrow range of salinity. Their cells rely on the surrounding salt concentration to maintain internal balance through osmosis. When that balance collapses, their bodies cannot regulate fluids. Fish absorb excess water, cells swell, organs fail. Coral reefs bleach not from heat but from chemical shock. Entire ecosystems unravel in silence beneath the surface. Phytoplankton, microscopic organisms responsible for producing a significant portion of Earth's oxygen, begin to die in massive quantities. These drifting plants form the base of the marine food web. As they collapse, everything above them follows. Dead zones expand. The ocean, once vibrant with unseen life, becomes chemically unstable and eerily still. Coastal communities witness the consequences. Within weeks, fisheries collapse almost overnight. Ports that once thrived on seafood exports fall quiet. Markets from Tokyo to Lisbon report shortages. Prices surge. Governments release emergency statements urging calm, but supply chains fracture under pressure. Climate shifts arrive more slowly, but with deeper impact. As thermohaline circulation weakens, regional climates lose their anchor. Northern Europe begins to cool rapidly, even as other parts of the world experience intensifying heat. Monsoon systems destabilize. Agricultural seasons shift unpredictably. Crops fail in regions that have relied on stable rainfall patterns for centuries. The jet stream, influenced indirectly by ocean temperatures, begins to meander. Storm systems stall longer over land. Floods intensify in some regions while drought deepens in others. Insurance markets strain under escalating disasters. Reinsurance firms collapse. Financial systems, already fragile, absorb another shock. Politically, tension builds along coastlines. Fresh oceans alter naval strategy in unexpected ways. Saltwater corrodes ships. Fresh water does not in the same way. Naval engineers scramble to understand how buoyancy and propulsion are affected by the new density of the seas. Submarines must recalibrate ballast systems. Sonar behaves differently. Military planners confront a maritime environment that no longer follows familiar physics. Desalination plants, once vital in arid regions, become obsolete overnight. Coastal cities that depended on them face a strange irony. The ocean is now fresh, but undrinkable due to contamination, biological decay, and chemical imbalance. Infrastructure built around salt removal cannot simply reverse its purpose. Engineers work feverishly to adapt systems not designed for this reality. Religious interpretations spread across social networks. Some see the loss of salt as symbolic, a purification, or a warning. In ancient texts, salt represented permanence, covenant, and preservation. Its disappearance feels like the removal of something sacred. Places of worship fill as uncertainty spreads faster than scientific consensus. Meanwhile, inland populations feel a delayed but inevitable pressure. As fisheries fail and coastal economies contract, migration begins. Jobs vanish. Entire port cities face economic depression within months. Governments attempt stimulus measures, but global trade patterns have shifted violently. Nations dependent on seafood exports enter recession. Food insecurity spreads. Ocean chemistry continues to evolve in dangerous ways. Without salt's buffering capacity, pH levels fluctuate more dramatically. Harmful algal blooms multiply in the unstable environment, releasing toxins into coastal waters. Beaches close indefinitely. Tourism industries collapse alongside fisheries. Wildlife, dependent on marine ecosystems, begins to disappear. Seabird populations crash as fish stocks vanish. Marine mammals strand themselves in greater numbers, disoriented by changes in buoyancy and sound transmission. The ocean grows quieter, biologically emptier, as if it is slowly forgetting how to sustain life. Scientists struggle to explain the origin of the event. Geological records show no precedent for a sudden global loss of salinity. Theories emerge: massive freshwater influx from accelerated ice melt, unknown chemical reactions, atmospheric anomalies, but none account for the speed and totality of the transformation. The event resists easy explanation, leaving humanity with consequence before cause. As years pass, a new equilibrium begins to form, but it is colder, harsher, less forgiving. The stalled ocean currents lock certain regions into prolonged winters. Others endure relentless heat without the moderating influence of moving water masses. Agricultural zones shift northward. Political borders strain under climate migration. Economies restructure around synthetic food production and controlled environment agriculture. Nations invest heavily in lab-grown proteins to replace lost fisheries. The romance of the sea fades, replaced by a cautious, almost clinical relationship with what was once a source of wonder. Children grow up without tasting wild-caught ocean fish. Coral reefs exist only in archived footage. Coastal cultures that defined themselves by tides and salt air lose a part of their identity. Language itself changes. Metaphors drawn from the sea lose their relevance. And still, the water remains fresh. Waves continue to crash against cliffs. Ships still cross vast blue expanses. From a distance, nothing appears different. But beneath the surface, the chemistry of life has shifted. The invisible scaffolding that stabilized climate, nourished ecosystems, and quietly supported civilization has dissolved. Earth does not end in fire or impact. It simply adjusts to a quieter, emptier ocean. Humanity survives, but in a world less abundant, less predictable, and subtly more fragile than before. The horizon looks the same as it always did, but something essential has been washed away, and it is not coming back. And somewhere in that quiet absence, the planet feels unfamiliar in ways we may never fully understand.
I'll be back.